Hi, hello everyone. So today's topic is perceptron. So here I have written all the important concepts related to perceptron. So let's discuss all the things line by line. So here first important point is related to perceptron. First thing I like to tell you, perceptron is one of the important concept in our machine learning, and basically you are used for classification task. So now let's start, and we have to understand how really perceptron doing. So before that, the simple concept I would like to discuss what is perceptron is. So here you see perceptron is the simplest type of artificial neural network used for binary classification task. Let's first understand this line. So first thing is, it is one of the simplest type of artificial neural network. So let's start. What is artificial neural network? Artificial neural network is also one of the important concept in machine learning, AI, deep learning. So artificial neural network, actually it gets the concept from biological neural network. I hope all of you know what is biological neural network. Inside our human brain, you know that millions of neurons are there, and they are doing certain kind of processing type of task. For example, we are watching dog, cats, or anything we are watching, and the whatever we are watching through our inputs, that through our eyes, that inputs go into the brain, and inside all the neurons are there. They are doing certain kind of processing task. Okay, so in the same manner, in the same concept we have taken, and in neural network, basically in biological neural network, millions of neurons are there. And here in the same manner, if instead of taking one neuron, we can create artificial neuron to do some kind of processing task. So that simple one neuron, basically this is not real neuron inside our brain, biological neuron, but the same what biological neuron doing, the same task can be done, same type of processing can be done using in our basically machine learning to do some kind of calculation, computation. Okay, so this is a neuron, and this neuron takes inputs, different types of inputs. Okay, and finally it is going to produce some kind of output. Basically we are doing for classification task, and how it is working we will discuss. So like our human brain, the neurons takes inputs through the dendrites. Do you know, for example, a mosquito if bite, best example in biology, if a mosquito is biting here, this signal, that electromagnetic signal, that electrochemical signal passes to our brain. Why? Because inside our whole body nervous system is there. So if a mosquito is biting, that signal is directly going to our brain. So basically that signal going to the neural network, and each simple unit is a neuron. That neuron receives that signal through the dendrites in biology. But here, that a simple neuron we are telling is perceptron receives through the inputs. So here also inputs are there, and it is also doing some kind of calculation. For example, mosquito bites happen, and that signal coming to a simple biological neuron. After that, for example, sometimes the mosquito biting is not that much hard. They are biting very clever, they are biting very slowly. So at that time, our brain cannot recognize. That means that signal is not that much hard, not that much more. If signal strength is less, then so at that time output is zero. That means we cannot understand that mosquito is biting. Many times mosquito biting we cannot understand. So at that time means after the signal coming to the neuron doing some kind of processing and produces output. That output is zero. That means I don't know that mosquito is still biting to me. But sometimes if mosquito biting is too hard, that signal strength is hard, and is coming and doing some calculation, and if that strength is more than some limit is there. For example, if some biting is happening, there is a limitation to tolerate that kind of bite. If that biting is crossing that limits, okay, crossing that limit, then is output, this neuron is going to produce output 1. That means it fires one kind of signal to beat that mosquito. In biology that is happening. In the same manner here, inputs are coming to this, and here it is also doing some kind of computation, and finally there is a threshold activation function. It is going to take the decision. So here if the strength, if the signal some computational strength, here the calculation strength is more than some range, it is going to produce output 1 or 0. So simple, I have compared with our biological neuron, how biological neuron receives in signals through the dendrites, doing some kind of calculation and take the decision. If strength is more than a certain limit, it is going to produce output 1. If strength is less than certain range or threshold, that output is 0. That is happening in the biological neuron. The same thing happening in the artificial neuron. So this same concept we are using to take some kind of decision. So first, I hope you understand what is artificial neural network. So this small unit, artificial neuron, if we collect a lots of artificial neuron, then we can create artificial neural network. Okay, so we are not going to discuss combination of more neurons. So here we are focusing to discuss one simple neuron and how a simple artificial neuron doing some kind of calculation. Okay, so I hope the first point is clear. So the perceptron is the simplest type of artificial neural network. I hope you understand simplest type of artificial neural network, a simple neuron, a simple artificial neuron. And basically we are used for binary classification task, means its output is 1 or 0. I hope it is clear. Now let's go to the second point. It is a supervised algorithm designed to classify data into one of the two categories. You know that binary classification task means two categories are there, either 0 or 1, yes or no. So here it is a supervised learning algorithm. I think you know what is supervised algorithm. In supervised learning algorithm, in the data set, we have inputs along with corresponding output is there. Okay, so it takes that kind of data set to train the model, and so it is basically supervised learning algorithm, and it is used for classification task or to classify either yes or no binary type. Third point is it computes a weighted sum of its input feature. So when the inputs are coming, and remember that in the data set, this x1, x2, what is this? These are the features. If there are 5 columns, then 5 input is coming. In the data set, if 2 columns, and then 2 feature or 2 columns, then 2 input is going to come to here. So it computes a weighted sum of its inputs. So inputs weighted sum means every input having some weights. So how to assign weights? Actually, what is the impact of the input on the output? If this input priority is higher, signal strength is higher, we have to assign its weight is more. So according to the impact of the you can say the input to the output, we have to assign the weight. If this input having more importance for the output production, then obviously its output its weight is going to be more. So I hope you understand. So here first it receives the inputs, do the weighted sum. Weighted sum means how it will calculate w1 x1 plus w2 x2 plus w3 x3, like that it is going to do the calculation, weighted sum. Okay, so it do the weighted sum of its input features it will do, and after it getting the weighted sum, the weighted sum is then going to pass to the activation function. Here activation function, how to produce the output? Normally different type of activation functions are there, sigmoidal function, step function, a lot of functions are there, but here basically in perceptron we are using step function. So step function what doing? If the signal, the weighted value z, if the z value is greater than a threshold, for example if you set the threshold 0.5, if the summation value z value more than 0.5, it is going to produce output 1. If this value is less than 0, less than that threshold 0.5, it is going to produce 0. So there is threshold value should be there in the question. Otherwise, step function treats 0 is the threshold value. If more than 0, output is equal to 1. If z value less than 0, it is going to be 0. So this kind of thing also it can use. So I hope this is clear. It first do the weighted sum. It first calculate the weighted sum of the input feature and applies an activation function. Here it is going to apply activation function to predict the final output here. Okay, so using that activation function is step function. Then another point here, so it is the foundational building block of our complex neural network structure. So if we combine many artificial neurons, then we can create the artificial neural network structure. And who developed this? Who invented? Frank Rosenblatt was invented in 1957 I think 1957, but it invented where at IBM in IBM 704 computer. It first created the Perceptron program. Okay, so he is an American psychologist. So he developed this Perceptron program in IBM 704 computer at Cornell Aeronautical Laboratory. So he developed this algorithm. So I hope you clear that this is a simple biology, it follows the biological neuron structure, and these are some important points related to perceptron. And another some key points you should know while you are working with perceptron. First, this is the input layers. Input layer means these are the features of the, you know that for if I create a data set, for example, let me create a data set and get data set. You know the AND get x1, x2, and it's the corresponding output equal to 1, y. So you know what is AND get. If I take 0, 0 is the input, AND get produces. So this is the AND get data set. So this is the AND get data set. So you can create AND get data set 0, 0. If 0, 0, output is 0. If it's 0, 1 combination, then you know that इसका output क्या होगा 1, 0. If 1, 0, then if 1, 0, output is 0. If both inputs are 1, then it is going to produce 1. So you see here in this data set how many input features? Here 2 input features x1 and x2. So if I want to build a neural network, it will be look like this. So here 2 input, you will get 2 input. One is x1 and another is x2. So here 2 input you will find. Okay. So I hope you understand what is input layers. So x1, x2, these are the features of a single input, single training example. And what is weighted? Weighted, it is given in the it is given already in your question. So it depends on the strength of the signal. If this input having higher value, higher priority, its corresponding W1, this value is going to be increased. So, and this part is known as the weighted sum. Okay, we will do next related to some numerical question on that. So how, see, weighted sum means you have to do W1 x1 plus W2 x2 plus like that. And here another term you find B. Here its input always 1 and its weight is known as B. It's known as, it's a bias. What is bias? Bias basically what happening, if you studied if you studied your linear regression. In the linear regression, the equation, you know the equation of the line is mx plus c. You know that. So this is the equation of the line. Y is equal to mx plus c. M is the slope, c the y intercept. If I draw a line format, if I draw a line like that, you know that this is your x axis and this is your y axis. Okay. So if c equal to 0, there is no y intercept, then this line will pass through the origin. Okay. So in some question you will find this bias is not available, only W1 x1, this part is not there. That means whatever we are predicting, actually it is creating a line, finally creating a linear line. So if this value is not, so if this is the decision line, if this is the linear decision line, and this is C, or you can say this is B here, what is doing? If B value 0, this line will pass through this origin. If the value equal to, if here the B value is equal to 1, then what will happening? It will pass through like that. So this value is, you know that your y intercept, this is B, okay, equal to 1. That means this is the decision boundary. If this is the decision line, so B determines it shifts the decision line. So it may be line may go through this or line may go through this. You know that in linear regression we are predicting line and the impact of this C. The same manner here also the bias term is there. The bias term tells us or it shifts the decision line. Okay, if no value there, it is going through the origin. If otherwise, it going, if some values, the line is going through like that. So bias having some impact. Okay, then this is the weighted sum. I think it is clear. And what is activation function? Here basically we are using step activation function. If this value, some value greater than threshold, for a threshold is given in the question, otherwise 0 you can take, more than 0, 1, less than 0, minus, sorry, 0 or minus 1, like that we can say. So here, and this is the predicted output. This neural network predicting the output. We'll do one or two simple question how a neural network structure is there, how it is going to predict the output. We'll discuss. Okay.